And it's time to press pause once again and to attempt factorising the following expressions. Of course, like always, once you're done, make sure you press play and check your answers against mine. Alright, so as you can see, here are my solutions. So for part A, we've got 3x squared plus 10x plus 3. So we've got three terms and we've got an a value out the front. What we need to do is we need to multiply the a by the c, that is the coefficient of the x squared, by the constant value. Right, so 3 times 3 gets us 9. And now what we do is we look for the factors of 9 that add to 10. Well, I know the factors of 9 are 9 and 1, and I know that 9 and 1 actually adds to 10. So how I've written that out now is, instead of writing 10x, I've written 9x plus x, because 9 and 1x, and 9x plus x is equal to 10x. So I've expanded the 10x and broken it down into two parts. Now that we've got four terms, we can factorise this quadratic expression as if it's four terms. So you've got 3x squared plus 9x plus x plus 3. Okay, so we collect the ones that have common factors. So you've got 3x squared plus 9x in the first bracket and x plus 3 in the second bracket. What we can see here now is I can take out the common factor of 3x, because 3x goes into both 3x squared and 9x. And 3x times x is 3x squared, and 3x times 3 is 9x. So you've got 3x out the front and x plus 3 in the brackets. You've already got x plus 3 in this bracket here, so what we're going to do is just take out the factor of positive 1. So now that we can see the common binomial factor of x plus 3 in each of the brackets, what we can do is we can write the 3x plus 1 in the first bracket and the x plus 3 in the second bracket, showing us that we've actually factorised 3x squared plus 10x plus 3 down to be 3x plus 1 and x plus 3 in the second bracket. Going through the same process again for this one, we've got three terms, so we're going to factorise according to the three terms. Do we have an a out the front? Well, we've got 20x squared, so yes, we do have an a value at the front, so we're going to use this one here. Now we've got 20x squared plus 3x minus 2. So in order to do that, what I need to do is multiply the first and the last term, so 20 times negative 2 is equal to negative 40. Now what we need to do is think factors of negative 40 that add to positive 3. So if I think long and hard about this, what I'll get is 8 times negative 5 will get me negative 40, and 8 minus 5 is positive 3. So what I've done is I've written positive 3x out as being positive 8x minus 5x. If you think about it, 8x minus 5x is equal to 3x, so it's actually equal to the same thing. We've just broken it up so that we've got four terms, and we can now factorise as if it's a quadratic expression with four terms. So what we're doing now is I've gone through and put brackets around the first two terms because they've got common factors, and brackets around the second two terms with a plus in between. So taking out the common factors now, I get 4x times 5x, because 4x times 5x is 20x squared, and 4x times 2 is 8x. Alright, taking out the common factor of negative 1, because the negatives here don't look pretty, so you take out negative 1, and you get 5x plus 2 again in this bracket. Once again, the common binomial factor of 5x plus 2 means that we can write it here, and we write the 4x minus 1 in the bracket out the front. Therefore, 20x squared plus 3x minus 2 is equal to 4x minus 1 times 5x plus 2 in brackets. Now part C I've put in there a little bit to trick you, because if you have a look, you've got 5x squared plus 15x plus 10. So at first inspection, what it looks like is we've got an a value because we've got a number out the front. Well, what you need to do is think again, because if you go back to our very first step when factorising quadratic expressions all the way up here, what it says is take out any common factors. Alright, so what I've done is I can see that you've got 5x squared plus 15x plus 10. That is, 5 goes into this one, and this one. That is, it goes into each one of the terms. So I've taken out 5 as a common factor, and you've got x squared plus 3x plus 2, because 5 times x squared is 5x squared, 5 times 3x is 15x, and 5 times 2 is 10. So the common factors come out. Now what we can do is we can treat this one here as if it's three terms but without the a value, because we kind of ignore the 5 for the rest of the working out. So if it's got no a value, what we're going to do is we're going to use the working out that you can see up here, that is the x squared plus bx plus c. So in order to do that, what I need to do is I need to look for the factors of 2 that add to 3. So what are the factors of 2? Well, you've got 2 and 1. Now, does 2 plus 1 equal 3? Well, it certainly does. So what I'm going to do is I'm going to write this factor here in this part here, and this factor here in this area here. So you end up getting 5 out the front with x plus 2 times x plus 1 in brackets. So although that looked like you're going to use the ax squared plus bx plus c method, remember always to look for common factors first. Now, if you didn't do this way, you could actually still get the same answer, so let's check out the working out for that. So if you have a look here, what I've done is I've gone 5 times 10, because you've got three terms, so 5 times 10 is 50. And now I'm looking for the factors of 50 that add to 15. Well, the factors of 50 of course are 5 and 10. Right, and of course 5 plus 10 is 15. So I've broken up this 15x into 5x plus 10x, and I've got 4 terms now. So I put brackets around the first two terms, 5x squared plus 5x, with a plus in the middle, and brackets around the second two terms being 10x plus 10. Right, now I've factorised the 5x squared plus 5x, taking out 5x as a common factor. Now 5x times x is 5x squared, and 5x times 1 is 5x, so that's how you'd factorise that one there. And taking out the common factor of 10 here, so you get 10 times x plus 1, because 10 times x is 10x, and 10 times 1 is 10. Alright, you can now see the common binomial factor of x plus 1, both here and here. So we've written that down here, and we've written 5x plus 10 out the front. Now if you think about it, we can still factorise this 5x plus 10 by taking out a common factor of 5. So what I've done here is I've taken the common factor out of 5, and of course 5 times x is 5x, and 5 times 2 is 10, and you're still left with the x plus 1 here. So you can see that both ways work and you'll get the same answer eventually, but I find that taking out the common factor first makes it a little bit easier.